Assuming that there is a deadly threat to us in the sky, and that its appearance will have disastrous consequences for the people of Earth, and maybe the actual planet itself, just what is this NIBIRU that so many people speak of? If we know so much about what it will do to us, surely we know what we're looking for, right? Some people say that NIBIRU is a planet. It could be a gas giant, like Jupiter, or a smaller terrestrial planet like our Earth. It might have moons, it might not. It may even have life and civilizations far more intelligent than our own. Strangely, it may have wings or tails, though their purpose or composition is completely unknown. Others say that it is not a planet at all, but a brown dwarf, a star, and that it too may have a planet orbiting it. It may have 2 planets orbiting it. It may even have up to 7 planets and 10 moons. Others disagree further, saying that it's a starship that exists only in the 5th dimension until the time is right to appear and destroy Earth. Whatever the object, the majority of believers will say that it's coming, and if it's not within our solar system already, it soon will be. It could appear here, beyond the orbit of Neptune, or maybe swing by here near Mercury, or simply plough right through the middle, straight towards Earth. But with all these conflicting viewpoints as to what NIBIRU actually is, how are we to go about finding proof of it? We can't focus on brown dwarfs if we should be focusing on rocky planets, and we can't focus on interdimensional starships at all, really. If believers make up their minds and tell us what we should be looking for, we can narrow down the search for such an object. Sounds reasonable, yes? If we knew what we were looking for, we'd all be on the same page, aware of the same object, whether there was evidence for it or not, and whether we believed in it or not. So what I ask here then is simple. What is NIBIRU? This is NIBIRU. It's a beautiful image. One of those sentences is a lie. What you see here is a star called V838 Monocerotis, about 20,000 light years away from our Sun. Looks a little funny for a star, doesn't it? That's because in 2002 it had a major outburst, and in a matter of months its appearance had altered pretty drastically. But how are you meant to know that? Who needs to know about stars that are thousands and thousands of light years away from us? None of us. That means I can swap this boring old sciencey caption to read something a little more sinister. And there we go, one mysterious planet. By using 2 images of a star whose outer shell is seen to be expanding, and to relabel it as a planet getting closer, NIBIRU believers have all the proof they need to convince someone who doesn't know the truth and doesn't want to ask for the truth. With knowledge of a planet coming closer and closer, so they say, you'd have thought believers would keep an eagle eye out for the next image showing the event unfold. Maybe we'd be able to pick out land masses or signs of life. Unfortunately for them, it started to look less and less like a planet, more and more like... And so, whenever you see these images claiming to be NIBIRU, and yes, the early images are still being claimed as such, you can tell people what it really is.
It's coming right for us! Kick ass!
In 1983, the first ever space-based observatory to survey the skies at infrared wavelengths was launched from California. Its name was IRAS, the Infrared Astronomical Satellite. Being the first of its kind, you can imagine that the data it gathered would be largely unknown to many people. Indeed, some things are still waiting to be identified, but then there are hundreds of thousands of them to go through. We are talking about 96% of the entire sky here, and seen in infrared. Where then does NIBIRU fit into all of this? Back in 1983, IRAS briefly made headlines with the discovery of an unknown object, described as possibly as large as the giant planet Jupiter, and possibly so close to Earth that it would be part of this solar system. Sounds like NIBIRU, eh? At last we have definitive proof. Except that we don't, of course. No, these unknown objects were of course studied in detail and found out to be distant galaxies. Distant galaxies, by definition, don't exist inside solar systems and are slightly larger than Jupiter.
Okay, one last time. These are small, but the ones out there are far away.
The Washington Post article even goes on to quote Dr. Jerry Neugebauer regarding speculation that it might be moving towards Earth, who says, "It's not incoming mail. I want to douse the idea with as much cold water as I can." Not NIBIRU then, not at all. Which is strange, because it has been known what IRAS has seen for more than 2 decades now, and still it is falsely used as proof of NIBIRU. So, when you hear a believer bring IRAS to the table, politely tell them to take it back.
Small, far away. Forget it.
Back in the mid-80s, when IRAS first brought us its infrared imagery, some objects just leapt out, appearing unlike anything else. Since the advent of easy-to-access sky maps from the likes of Google and WikiSky, IRAS imagery could be brought forward to allow anyone to have a look at the types of sites it saw. Indeed, for a time it was even possible to type NIBIRU into the WikiSky search box and be brought to this object. That must be proof that it's NIBIRU, right? Wrong. Some of those working on the IRAS data had the same reaction you might have had upon seeing this imagery. Some said it could have been a 10th planet due to it sitting near the ecliptic, the plane of the planets, but all of them did what they do best. They researched it further. This object isn't NIBIRU, but a carbon star about 650 light years away known as CW Leonis. What's so special about this star compared to other stars? Why does it have this striking appearance in the infrared? CW Leonis, found in 1967, is an ideal object to study in order to understand things like mass loss in the late stages of stellar evolution, essentially where all the stuff from a star goes during the star's death. It is so ideal for study, in fact, that it's the most studied carbon star that has been discovered, and quite a bit is known about it. Being a carbon star simply means that there is more carbon than oxygen in its atmosphere, and the processes that take place here lead the star to be caked in soot, if you will, surrounded by a thick shell of dust comprised of all manner of molecules. With the rate at which the star is losing this mass, and that mass going on to form an envelope around the star, it turns out that it's hard to see the star itself in visible wavelengths. In fact, it was only discovered because it was visible in the red band of the Palomar Observatory Sky Survey and not the blue, as you can see from these images. In later surveys with multiple wavelengths, like the Sloan Digital Sky Survey, have shown the emissions from CW Leonis are towards the red and mostly the infrared end of the spectrum. But how can we be sure that this object is CW Leonis and not NIBIRU? To begin with, let's make sure we have the correct coordinates. We can search Simbad, an astronomical database of some 4.8 million objects, and it returns a star name, CW Leonis. So far so good, these coordinates are known to be those of the star we're looking at. But do they definitely point to the strange looking feature in IRAS? Well, let's have a look at the many catalogues available to search through at the Infrared Science Archive. We can choose to search the IRAS catalogues directly, so we can see what IRAS saw and in the wavelengths it saw it. Sure enough, if we put in our coordinates for CW Leonis, we see the same feature that we see in WikiSky. So with what we know and have studied about the star since the late 60s, and with coordinates and data that support the view that we're looking at the same object, we have an abundance of evidence for this object to be CW Leonis. What evidence do we have for it being NIBIRU instead? Well, when it was listed as a search term, we were brought here. Unfortunately, we're going to need a bit more evidence than that. SkyMap is built upon the ideals of a wiki, hence its second name of WikiSky, and it is something that anybody can add to and enhance for the benefit of the users. It is therefore entirely possible that NIBIRU's inclusion as a search result was a little joke, a nod to the 80s when this was first thought to be something other than a star. It could even have been someone hunting for anomalies and naming them NIBIRU without researching them properly. However, you may not take any of that as an acceptable answer from me. You may think that it's been covered up as part of the conspiracy, for example. You may not even accept that this feature is CW Leonis in the first place. If so, here is what you need to do. There are hundreds and hundreds of catalogues that can be searched through, from multiple sky surveys, from different satellites across many wavelengths, studying various kinds of objects. We can do this extensive research for any position in the sky you wish to name. Get the coordinates that you think show NIBIRU. Test them against these massive databases to see what is known to exist at that position. Alternatively, if you think we are already looking at NIBIRU here and not CW Leonis, then expand your research and tell us why it cannot be CW Leonis. After all, if your evidence for it being NIBIRU is stronger than the evidence that says it is CW Leonis, then you and your claims are in a very good position. Ask yourselves this, for example. CW Leonis hasn't moved since the 50s, when the first sky survey imaged it, through to the 60s when it was discovered within that data, the 80s when the IRAS took a look, the 90s when the SDSS imaged it. But isn't NIBIRU supposed to be a moving object? Searching through endless databases full of astronomical jargon sure isn't as instant and pretty as searching on WikiSky and Google, but it is a necessity in order for you to make a solid claim. If you don't use them to prove NIBIRU, then others will use them to counter your arguments. As I have said often enough, if you want NIBIRU to be taken seriously, you must put in the research. We ask for nothing more than testable evidence, and yet we're provided with nothing but nonsense. This is Soho, a district of London known for its nightlife, not for NIBIRU. This, however, is SOHO, the Solar and Heliospheric Observatory, a spacecraft launched in 1995 to study the Sun. Among its many instruments is a firm favourite of NIBIRU believers, the Large Angle and Spectrometric Coronagraph Experiment, or LASCO. LASCO monitors the solar corona, but due to it looking at the Sun its entire life, it also sees our planetary neighbours pass in front of and behind the Sun. It's even seen the odd comet or two fly past like this. So how do we know that these objects slowly moving across our view are the planets we know and love, and are not NIBIRU? That is, how do we know other than using this handy calendar of events on the website for LASCO? Well, a simple method that anybody can try is a free program called Celestia. Celestia offers us a 3D view of time and space where we can fly to any object and see it from any angle at any speed. What this means for us here is that we can position our Celestia camera at an angle and date similar to where SOHO was and see for ourselves what was in view. We know that SOHO orbits the L1 Lagrangian point, about here, so we can put our camera along that same line of the Sun, SOHO, Earth and get the same view. Here is an image from LASCO, taken on December 15th, 2009, and here we are in Celestia, December 15th, 2009. We see Venus, and sure enough, the transit calendar shows Venus for this date. It even shows direction, and back in Celestia we can speed up time and see if Venus is travelling the right way too. And there we have it. From this view, we can even see the next transit of Mercury, then Venus, and if our view is further out, Neptune and Jupiter too. So, whenever you see a blue image like this, just remember there are plenty of places where you can find out what you're looking at. Sometimes though, believers will point to a LASCO image full of strange shapes, often calling them winged planets, which of course makes a lot of sense. Planets can have wings, right? In this case, and indeed the cases for many other bright objects you see in the images, including the planets and comets you saw before, you're just seeing the effects of a very bright light hitting the CCD chips of the LASCO camera. To use an analogy by Phil Plait, author of the Bad Astronomy blog concerning, among other things, cases of bad astronomy from people who think they know about astronomy, you can think of a CCD chip as an array of buckets in the rain. Each bucket, or pixel, collects the rain, or light, where more rain in any given bucket, or light in a pixel, results in a brighter area of the image. In the same way that a bucket of rainwater can overflow, so can a pixel with too much light hitting it. Light hits the CCD chip and is converted into electrons, ready to be read off as an image. But there are too many electrons for that one pixel to take, too much rainwater for one bucket, and so it spreads. The rain flows into the buckets beside it, so do the electrons in the pixels. This can happen again and again until there is enough space for those raindrops in their buckets, and when it comes time to read the amount of electrons in each pixel to create an image, blooming has appeared. For those who are interested in this in more detail, check out the complete article by Phil, including examples from SOHO and Hubble, where he spent 5 years working, so he knows his stuff. To finish, yes, some things from LASCO look pretty strange to you and me, but to the people who work on the data these images record every day, it's just same old, same old. SOHO isn't the only satellite whose focus is the Sun. A pair of satellites were launched in 2006 called STEREO, the Solar Terrestrial Relations Observatory. The satellites are much further away from Earth than SOHO, such that one orbits the Sun earlier than the Earth in a sense, and one trails behind the Earth, allowing us to view the Sun from two different viewpoints at the same time. As with SOHO, some armchair astronomers are quick to notice the strange and unusual within the imagery sent back. This little side video does not directly concern NIBIRU, though looking hard enough I'm sure somebody could say that they found it. Instead, this is a response to a video asking us to look long and hard at the images and say what we see. You know, forgetting all that science nonsense. I mean, sure, they look like coronal loops, a common feature of the Sun's corona, but of course they're not, right? What's more, we're asked to take the images at 1024 by 1024 resolution, then scale them down to 20%, and then say what we see, as long as what we see isn't a coronal loop, a mass ejection, a sunspot, and so on. If you're thinking this is a little strange, you're not alone, but you can try this too, if you must. Images from both stereo and SOHO from any instrument are searchable and downloadable. They're available to anyone to browse through and see for yourselves the usual goings-on of the Sun. So, without further ado, Image 1 looks pretty cool. The Sun as seen by the extreme ultraviolet imager on the behind satellite, so the Earth is off to the right somewhere. We're meant to look into these two areas. Both appear to me to be coronal loops, nothing unusual about that. Right, what on earth have we learnt by doing this? Firstly, I've got too much time to have even bothered to do this. Secondly, we obviously can't do science like this, squinting at an image and saying what we see. We're losing sight of what we're actually looking at, a snapshot in time of a coronal loop on the surface of the Sun, and instead trying to see something else. Which is, of course, our third point, the wonders of pareidolia, seeing faces and figures in random patterns. The vast majority of what I claim to see had a face in it, and because of the slow changing nature of the images, I was remembering the shape I saw from the previous image and looking for it in the next image as a starting point. This gets us absolutely nowhere. I've just shown you a video of activity on the Sun and said that I could see a rather calm predator. What use is that to anybody? Let's end this video on something useful. By all means, look at the thousands of images that come from these satellites. Enjoy them for what they are. Be interested in them for showing an object we see every day in an entirely new light. But don't claim to see what isn't there. The Sun doesn't have a face. It isn't communicating the future to us. To think otherwise is to completely ignore the already cool stuff going on. The stuff that science knows about. The coronal loops, the sunspots. Just don't fall for nonsense.
Can you tell what it is yet?
No.
As the previous video has shown, many satellites have been sent into space to watch the solar activity, keeping an eye on everything from sunspots to mass ejections. Indeed, another was launched in February this year, the Solar Dynamics Observatory, where it will sit in a geosynchronous orbit, taking one image every 10th of a second from multiple cameras. And that geosynchronous orbit means that we'll be able to see those images faster than any other satellite like SOHO and stereo. And they'll be of even greater quality. Let's not forget that SOHO takes pictures with cameras that are nearly 15 years old now. The SDO's camera are high definition in comparison. What does that mean for NIBIRU? Well, I'm sure that as soon as photos become available, it'll mean believers sifting through them one by one, hoping to pick out funny looking blobs or dashes, anything that doesn't make sense to them, and must therefore be a planet headed towards Earth. If only there was some way of harnessing that energy and using it to further our knowledge of science. Oh wait, there is! To make a YouTube video exposing... to identify objects and events in an easy to understand and almost game-like manner. Enter Solar Storm Watch, a website that simply asks, can you help? You see, as good as scientists are, they could do with more pairs of eyes. What this website does is simple. It allows everyday people to see what scientists see and to catalogue it for them. That is to say that once you've registered for free and completed a very helpful tutorial on what to look out for, you can begin evaluating imagery from stereo's cameras. The primary focus is on solar storms, and whether you can spot them, see when in time they began, which cameras saw them, and so on. Anything that scientists can use to give them an idea of what happened. You can even go through the videos to identify other events, like comets, particle strikes, or optical effects like lens flares, all of which you'll have been trained to spot so that you know what to look out for. If you're experienced enough, you can even have a go at the beacon mode data, low quality black and white data transmitted on a faster timescale than the higher quality data, but still an early indication of what has happened on the Sun. You can submit anything and everything you see, and it all goes to helping the team learn more about solar activity. Or you could make a YouTube video claiming it to be one big government cover-up. If however you are interested in Solar Storm Watch, check out the other projects as well, including Galaxy Zoo, where you can classify galaxies or hunt for supernova. I really hope there are some NIBIRU or Planet X or whatever believers watching this video who do at least check this out. You can help the world for once. You might even be lucky enough to discover a new object, like Hanny's Voorwerp, found by Dutch schoolteacher Hanny van Arkel while she was classifying galaxies on websites like these. You can genuinely help science here. You have the perfect channel in which to ask people what you're looking at and be told the answers. But unfortunately, I expect you won't do such a thing. How's about you prove me wrong? How's about you watch for solar storms?
Well, one way that people can get involved, of course, is we have a project called Solar Stormwatch, which we've launched with the Royal Observatory Greenwich and the Galaxy Zoo team to get people to actually look at stereo data and track these storms with us. And it's providing a really valuable insight into the behaviour of the sun. And there is even the possibility that you could be able to detect them in real time and provide one of these alerts. We're right at the very beginning stages of this process, but people can actually get involved with this project by going to the website, which is www.solarstormwatch.com, and their help will be really valued by us, because we've got so much data, and the more people looking at it, the more we'll find.
It shows that a song is one chance where everyone, professional and amateur, can get involved. That's true.
Absolutely. Absolutely, yeah.
I can't believe this has happened so quickly. Launched in February, the Solar Dynamics Observatory was the next best satellite to be sent up to watch the sun. I expected that, upon its imagery being revealed to the public, that someone somewhere will be combing through it looking for evidence of NIBIRU and so on, because as we all know, any strange goings on in the sun that we personally don't understand must be evidence for the ever-elusive NIBIRU. First Light was officially announced on the 21st of April 2010, offering worldwide audiences a selection of movies. Some flat-out stunning movies. Download them yourselves, words cannot describe how brilliant they are. Within a day, however, if that, they were being shown on YouTube as evidence of impending doom. I would have replied to this particular video in its comment section, but I am of course blocked by this user. Let's take a look at the description of this video. Massive solar flares have NASA speechless. Amazing everything is happening now. NIBIRU must be getting close. Now, I for one can safely say that I don't study the sun. I'm also willing to bet that you don't study it either. That is to say that you have no idea what's going on in those images. Well, to give you credit, you know that it's a solar flare, but beyond that you know what exactly? If we were content with our knowledge of the sun, we wouldn't have bothered launching the SDO. But we're not content. We want to find out about our sun because, wait for it, we don't know enough. Science doesn't know enough. So if science doesn't know the full picture yet, what makes you think you do? Sure, ask questions, but don't jump to conclusions. In your attempt to ask questions, you've already tried to persuade your beliefs upon your viewers. NIBIRU must be getting close is an assumption that NIBIRU exists and is to blame for solar activity. Amazing everything is happening now is you remembering select events, speculatively linking them together in a way that suits you, and forgetting the concept of time. Now this may sound harsh on my part, it certainly feels pretty ranty rather than composed, but I hope you get the point of my message here. This stuff is awesome, there's no denying that, but there are far better people suited to the task of identifying these things, far more educated people. And that's not an attack on you, as I said before, I don't study the sun either. So how about, instead of misinforming YouTubers by bringing NIBIRU to the party, we simply follow along with the progress of the SDO, be interested in its new discoveries, and enjoy it for what it offers us, a view of the most beautiful star in the galaxy. In what is becoming my most active area of the NIBIRU Nonsense series, I once again return to all things stereo. Recently, videos like these have cropped up on the internet as proof of NIBIRU, or at the very least, proof of the unknown. What we are looking at is a single output from the Stereo A satellite, and when I say there is nothing unusual in this image, I mean it. The blob that people think is NIBIRU simply isn't. It's Venus, and there are a number of ways to find that out. Now we know this is a stereo image, so let's take a look at the stereo website. Firstly, we can look at a map, the locations of both satellites, the Earth, the Sun, as well as Mercury and Venus. We can already see that Venus is in view as the ahead satellite. On another page, we can even input dates up to 2015 to see where these objects are. But I know you NIBIRU believers too well. You're not satisfied with that, so let's go to another page on the site, the Planet Finder. The Science Centre's Planet Finder page shows recent imagery highlighting the planets, as well as offer us links to much more sources of imagery. We can already see, for example, that Venus is a known object in these images. It's even been circled and labelled, but that must obviously be part of the conspiracy, right? So let's go back to our good friend Celestia, and yes, sure enough, Venus is in our view. But if you're still not sure, and you still want to talk to someone, there are contact details on both the stereo page and Sungrazer, a website with information for stereo and SOHO imagery, transit paths, and even a guide to all the strange sites and what they actually are. And yes, they do answer their emails, I've checked. The reply indeed said that it was Venus, as well as offering me sources for double checking. This is all you need to do. A little bit of research goes a long way, and I and many others have shown you where to get such information. So why do you still claim it to be NIBIRU? Back again, soon I'll need a new series. So in the last video I showed you why this image was Venus. I'm back to show you that it's still Venus, no matter how often you use the map to say otherwise. First of all, this map is a representation. The scales of the orbits are accurate. These numbers represent astronomical units, by the way. But the scale between the sizes of the planets and the Sun, for example, isn't so accurate. Now I know you're all smart enough to know that the Sun is an awful lot bigger than Venus, but is it big enough to block out Venus from the view of the Stereo A satellite? This dotted line represents the angular displacement from the Sun of each satellite. It does not show the satellite's field of view. Indeed, each instrument on the satellite looks at a different aspect of the Sun, and in turn each has a different line of sight and field of view. Some do look straight at it along the line, but some look more towards the Earth, to look out for solar storms and so on, the Sun itself not even entering their view. Stereo A's Core 2 instrument looks directly at the Sun, and because it's studying the solar corona, its field of view has to be large enough to capture the larger events. Let's look at the recent imagery we all know and love. In the same amount of space that Core 2 looks at, we can fit 15 suns side by side. That's a distance of 7 suns either side. Is nearly 21 million kilometres end to end, to give you a sense of scale. Now that wasn't brilliantly scientific, but remember it for later on. The key issue that you seem to have trouble with is that you say Venus is behind the Sun on this map, such that Stereo A cannot see it at all. But we know that this map has an issue of scale, so we need to look at this scene more accurately. I've said before and I'll say again that these things can be independently checked with other pieces of software, both online and off. And my application of choice is Celestia. This is a view in Celestia, looking straight down at the Sun, mirroring the view of our stereo map. We can check this by overlaying the stereo map, and sure enough the orbit and positions of the planets line up nicely. We now know then where the stereo satellites are in relation to this Celestia image, and importantly Celestia has an accurate depiction of scale. What we can then do is the ever scientific drawing a line over the top. Here's our first line, over the top of the stereo map. We're going from the centre of the red dot to the centre of Venus's dot, or at least as close as we can get. Already we can see that we cut through the dot representing the Sun, but we know these scales aren't accurate. How big is the Sun really? Will it be this big in Celestia, therefore blocking our view of Venus? Let's reduce the opacity of this layer and find out. Ah, that's interesting. Our line, the very same line from the stereo map, from centre to centre, does not go through the Sun. It doesn't get anywhere near it. Stereo A's Core 2 isn't looking down our newly drawn line, however, but straight at the Sun. If you remember, our field of view is equal to 15 suns side by side. What do 15 suns side by side look like in Celestia? They look like this, which gives us an estimation for our field of view from Stereo A to be this red cone. Our line from centre to centre is well inside the field of view for Core 2, and at the other end of it, Venus is well inside too. This line goes through the centre of the Sun to show you how far Venus is to the right from Stereo A's viewpoint. Venus is where it should be, it always has been, and now you know, once again, what this object in the recent imagery from Stereo is. That's stereo, not SOHO, as some of you have said. SOHO is a different satellite. It has a different viewpoint to that of both stereo satellites. The name and instrument is stamped into each image. There is no excuse for you not knowing where the imagery came from. So could you please do a little bit of research next time? Thanks. So, now the claims concern higher quality imagery that replaces the original lower quality images, and in doing so removing all references to Venus and leaving a bizarre looking shape to our eyes. In short, no, you haven't caught NASA with their pants down, nor have you caught them manipulating image data. But you have misunderstood how images arrive from the stereo satellites to the stereo website and beyond. And yes, it is an unusual shape compared to what we think we would see, but once again it's an expected shape to those who know how it is created. I think it's time to do some research to explain all of this. Indeed, doing research is the only reason I haven't made a hasty response to these recent claims. I was instead checking my information, as any one of us is capable of doing. So, let's get straight to it. Stereo A records its imagery and other data, telemetry and so on, and saves it on board. That data is known as the science data, and it is what will be studied back down on the ground. In the case of Core 2 data, it looks something like this. Getting it back to Earth, however, is a challenge, and a costly one too. To get the science data back, the Deep Space Network is called upon, a series of antennas that track down the stereo satellites and download their data, a process which can take hours. Once all the science data is downloaded to the DSN, it is then downloaded by those who will process the data. In the case of our beloved Core 2 imagery, groups at the Naval Research Laboratory download this data, process it, and send it on to the Science Centre and the website, and other groups who use the data. This whole process results in a 3-day lag. 3 days is far too long, especially when we're monitoring for solar storms, so stereo also stays in constant contact, but has to stream the science data back to Earth in a different form, at much less cost and on a much quicker timescale. More antennas download this heavily compressed data from the satellite's beacon mode, allowing us to get an idea of what is happening on the Sun as soon as possible. But it is only an idea. We cannot use low-quality beacon mode data to do science. We can make an educated guess, but we can only confirm it a few days later once the science data has been processed. This image is an example of what sort of content is sent in the beacon mode, and contrast that with the science data imagery for the same time. You can think of this process as taking a photo of a landscape, but first transmitting a rough sketch of the landscape so people can get an idea of what's out there relatively quickly, and then to take time in transmitting the photo itself. The two images are the same. This is the image Stereo A saw. It first transmitted a lower quality version that was uploaded to the website as soon as possible, and then it transmitted the higher quality image which was uploaded at a later date after being processed. There is a useful way to tell which version you're looking at if you're unsure, and that's to check the file name of the image. The beacon mode imagery will have a 7 near the end, and the science data will have a 4 instead, and it's as simple as that. If you really want to make a claim on the stereo imagery, make a claim on the science data, not the beacon mode, and that's exactly what some of you have done, so let's continue to find out why Venus appears to have a funny shape. And yes, it is still Venus. There is a simple reason for this shape, and it's due to the light from Venus diffracting off the occulter that blocks out the light from the Sun and bouncing around the optics of the instrument before being read off as an image. It's a known effect, and we can see it down here on Earth too. In any case, it's a strong light source entering delicate and precise optics. The Core 2 instrument isn't designed to look at planets, so it doesn't compensate, if you will, for any entering its field of view. It simply doesn't care that they're in view and just lets it happen. And yes, it has happened before, and yes, it was Venus then as well. And Mercury is in this image too. It doesn't have the butterfly shape that Venus does because not all planets are equal in the amount of light they reflect back from the Sun to the instruments in stereo. When I say things are normal in the imagery, I mean things are normal in the imagery, even if I have to double check what I've researched with the experts, the people who, by definition, know what they are talking about. They have contact information, they do reply to your messages, so if you need to, just ask them. I cannot stress enough how important research is. You're obviously smart enough to gather imagery from a variety of dates, instruments and satellites, so why can't you also browse the Western websites to learn how the instruments work, how the data is sent from the satellites, how CCDs are affected by light to create image artifacts. This is all available for you to read up on, and still you ignore it and jump to the conclusion that someone is hiding something or manipulating imagery. I know you have the curiosity and indeed the passion for this sort of stuff, so why do you not have the desire to actually learn about it too? Sometimes you'll hear of a telescope designed and built to find and track NIBIRU. Its name is the South Pole Telescope. I'll leave it to you to figure out where in the world that is. Unfortunately for believers, the South Pole Telescope was not built for NIBIRU, but for something much more significant, namely the rest of the universe. It studies the cosmic microwave background radiation, not a single rogue planet like believers suggest. You may even be told of a photograph of NIBIRU, straight from the telescope. Again though, something is afoot. The South Pole Telescope doesn't take photographs as we think of them. It instead records the amount of heat coming from the sky, in the same way that cameras record light. So it doesn't hunt planets, it doesn't care for them. It's concerned with far more interesting aspects of the universe, rather than one tiny blob of rock or gas or whatever NIBIRU apparently is. But of course, none of this will persuade someone who firmly believes that the South Pole Telescope is part of a government cover-up, where all its data of the CMBR and all the scientists who work on it and who spend their lives with it, all of them are just hiding the fact that its sole purpose is to track one single planet in the sky. What's easier to believe? No planet or polar conspiracy? There is a bit of history and a running theme with South Pole Telescope claims. The theme is that if you post a video containing imagery from the SPT, YouTube will delete your account. Good thing none of the NIBIRU proponents are actually using imagery from the SPT then, and are instead using fakes, or certainly images from anywhere but the SPT. And that's where the history comes in, with a user by the name of NIBIRU Shock 2012 posting a series of images, each more drastic than the last, until his account was deleted, hacked, taken over by them, whoever they are. Whatever happened to the account though, the video contents were confirmed by other NIBIRU proponents to be genuine. And by confirmed, I mean those proponents did no research into the SPT at all and then concluded that the images were genuine. There's a slight problem with that, especially when NIBIRU Shock 2012 later comes forward and owns up to the hoax, explaining that the images were photoshopped and even offering the original files used in his videos. Whether you're still skeptical about those events or not, and many believe that even this admission of a hoax is in fact a cover-up, then it shouldn't matter in the slightest, as you'll soon see. Another video has surfaced recently from the same proponent along identical lines. An image is carefully analysed and found to be genuine. Not only genuine, but detailed. Let's have a look. Looks red, looks like a blob, looks compressed. So what's the first step in the image analysis? Downloading it from YouTube. Wait, what? We're doing image analysis on a frame of compressed video showing a compressed image. Right. Compression 101. The aim is to reduce redundant data in order to store a file more efficiently, essentially making the file size smaller while trying not to impact what the image actually looks like. I'm sure you've all heard of a JPEG. JPEG compression is everywhere, from on the web to inside your digital cameras. As good as it is at compressing images, it is still a lossy compression format. That is to say, it will discard data that isn't needed, especially if you want a smaller and smaller file size. This is a red blob on a black background. The feathering is a product of the brush. We don't want sharp edges so we can see the effects of compression. The blob was saved as a JPEG with as much of that compression as possible. Not much has changed ultimately. The image is still a red blob on a black background, but a look at the image through the ever useful increased brightness and contrast vision shows just how much compression can affect an image. Now, after all that compression, we then upload it in a compressed video to YouTube, who compresses it in order to stream it to other viewers. And other viewers can then download a compressed version to watch offline. The levels of compression may not be as drastic as the example here, but they do stack up and affect each other. So let's continue following along with an image analysis that simply will not find anything other than image artifacts. Is this a natural star field in the background, or part of the compression process? It could, if the original image was a photo, be an imperfection on the lens, a speck of dust or what have you. A white fuzzy blob on a black background is not conclusive as a star field. This gradient looks familiar too. We're both going from a red blob to a black background, and yet we see greens and purples. This again could all be due to whichever form of compression was used, both for the original image and its video conversions. No evidence of sharp cut and paste corners. Not only have we just seen that you can create a red blob with just a brush and therefore not need to copy and paste anything, but the compression process doesn't care what you did to make the image, and it can even help to blur any cut and paste jobs, making this part of the analysis redundant. Oh good, image enhancement time.
Magnify that death spear.
Why is it still blurry?
That's all the resolution we have. Making it bigger doesn't make it clearer.
It does on CSI Miami.
We're looking for a distinct comet-like dust trail. Yes, we're looking for it. We aren't being shown it. There's a difference. If this is going back to our pareidolia days, we're put in a mindset of an object having wings and tails, and are therefore looking for an object with wings and tails. How many times have I used this image in my videos, for example? This is synonymous with NIBIRU. In order for an image of a winged, tailed object to be genuine, we must therefore find evidence for a wing or a tail, even if we have to zoom in, whack up the contrast, and wish for it to be there, despite looking at nothing but compression artifacts. And yet, there is a more glaring error than all of this image analysis. The claim is that the imagery comes from the South Pole telescope, a telescope that doesn't even take images of visible light, and certainly not images of planets. Here are examples of SPT data. It's boring, right? Even when false colour is applied, it's hardly a bright red planet with wings hurtling towards Earth, is it? The SPT is not concerned with planet hunting, never has, never will be. It deals with galaxy clusters found in the cosmic microwave background radiation, but then you need some sort of a conspiracy theory in order to mask how simple it is to create a fake image in Photoshop. More often than not, you'll come across photographs claiming to show NIBIRU in daylight. It may be a clear sky showing a colourful NIBIRU, or it may be a cloudy sky showing mysterious light sources. First of all, let's suppose that NIBIRU is up there, orbiting the Sun such that we can look up into the sky and see it clearly. We must also suppose that NIBIRU cannot change its form. It can't change its colour, its size, and so on. Sounds straightforward. Planets don't change colour on a daily basis. Why then are photographs claiming to show NIBIRU in daylight all different? And we're not just talking about NIBIRU being in different positions, we're talking about different colours and sizes. You know, of course, what I'm talking about. Lens flares. Anytime you point a camera at a bright light source, you're liable to end up with a lens flare of some sort. The more optics within the lens, the more chance there is of light bouncing around inside. Even taking a photo from behind a window can produce unwanted flares and light sources, because it's one more layer of glass for light to pass through. We also know that every lens will produce a different flare. The angles to the light source will be different, the aperture setting will be different, even the condition of the lens will be different. Some people cover their lenses when not in use, but others leave them open to the elements, leaving specks of dirt or scratches on the lens. Even drops of water can drastically alter an image, and often it's only when you get the images back that you can see imperfections in the lens. You're unlikely to see scratches through a viewfinder, for example. Things are even worse for mobile phones, where many such NIBIRU images originate. Plenty of models don't have lens caps, and plenty of phones are carried around in pockets or handbags, perfect environments for picking up dirt, dust and scratches. Despite all of these problems and the artifacts that are created when pointing electronics and optics directly towards the Sun, the claim by believers still stands. You can see NIBIRU in daylight with your own camera. Well, of course you can't, you're seeing lens flares and so on, and it's much easier to prove with video, so I went out and filmed some. You'll have to forgive the shaky footage, but I'll freeze frame where necessary. Now, I know what you've just blurted out, that's the moon, not the sun. Blimey, anyone can tell the difference between those two. And that's correct, the moon is not the sun. But that isn't the point of this experiment. The point is to illustrate that any strong light source will have effects on cameras, and the strongest light source that's pretty safe to look at is a full moon. So what you can see here is a light source behind the clouds. Immediately, I could see what many other NIBIRU believers see in their photographs, a second circular object appearing in front of the moon. Through the LCD display, I could easily tell that this was in fact another image of the moon. The actual moon was so bright that the camera could only pick out its shape, but the reflection it saw on the window was enough to pick out the details of the moon's surface. To test this, and to confirm it was the window reflection I and my camera were seeing, I opened the window. Sounds simple, doesn't it? And guess what? No reflection of the moon, just a large light source illuminating the clouds. I even picked out a nice green lens flare, showing again how optics and light can create strange things. This entire test took me 3 minutes, and I found 2 instances of what others would call NIBIRU. You can do this too, and you can see for yourselves that there is no planet out there in images like these. I'll say it again, I know this is the moon, but the principle is the same. You could test these things with a desk lamp if you needed to. Please note that looking at the sun for even brief periods can cause irreparable damage to your eyes. If you're going to look, Be very careful doing so, and if you start to see planets, consult a specialist. Our atmosphere is capable of many weird and wonderful things, many of which are so uncommon to the majority of us that we can jump to conclusions, and we know what kind of conclusions some people can reach. Imagine yourself looking at clear skies. No clouds, no aeroplanes, just the Earth's atmosphere and the sun. Light shines from the sun in every direction, so if you were with two friends, each a mile away from you, they too would see the sun. These are the longer wavelengths of light, the red end of the spectrum, and more often than not they're able to travel from the sun straight to your eyes unhindered. But the shorter wavelengths, the blue end of the spectrum, have a harder time. They bump into the molecules that make up our atmosphere and scatter in different directions, again and again and again, until they too come into your eyes. This is called Rayleigh scattering, and it's why the sky is blue. Light from the sun, from all directions remember, bounces around our atmosphere before coming into our eyes. Now, you don't need an atmosphere for funny things to happen to light. You might have seen the experiment with a pencil in a beaker of water, where the pencil appears to bend. This is called refraction. You might also have seen a rainbow, where light is refracted into a droplet of water, reflected off the back, and refracted once again on the way out. Water vapour, H2O, is the third most abundant molecule in our atmosphere, behind nitrogen and oxygen. By volume it's less than 0.5% of the total atmosphere, but what it does to light more than makes up for that. Under the right conditions, some of this water freezes and forms hexagonal ice crystals, most of them flat disks. These tiny disks, like beakers of water and water droplets in rainbows, can appear to bend light and redirect it off its original path. Now that these ice crystals are in the air, some of those longer wavelengths that would have gone straight to your friends a mile away are instead redirected towards you by these ice crystals. You can still see the light coming straight at you from the sun, and you can still see the light being scattered by the atmosphere, but now you can see some more light, sometimes enough of which to allow you to see sundogs. These are classic examples of unidentified objects in the sky, a second and even third sun, and to some people that of course means NIBIRU. But sundogs, or parhelia, always appear at the same distance above the horizon as the sun, and always at 22 degrees distance from the sun itself. They don't always look the same. Some look like objects giving off light, others look like mini rainbows almost. But if you see any apparent source of light in these positions, it is more than likely a sundog. So that isn't to say that every strange point of light is a sundog. Some are still lens flares, for example. But it's important to remember that we must definitely rule out that mysterious light as being an image artifact or atmospheric phenomena before we jump up and down and call it a new star in our solar system. If you call a light in the sky NIBIRU, you better have the evidence to back it up, and a video alone is not evidence. Ever wonder why there are far more photographs of NIBIRU than videos? In short, it's much easier to find one good-looking image than it is to find even 1 second's worth of video frames, even if searching for that one good photo can mean hours of work and hundreds of photos to sift through. And, if we don't find the perfect image, we can always tinker with it. Enter Photoshop. Image editing applications nowadays can drastically alter any image you throw at it with the wonders of filters and adjustments. In short, a filter will take the values of an image that concern it and alter the image accordingly. It might make an artistic change, giving the impression of a painting rather than a photograph, or add an effect, such as a false light or, if you wish, a lens flare. Each filter performs its own calculations based on what it sees in an image. If, for example, it sees a grey pixel that is closer to black than to white, and you choose to increase the contrast, that pixel will darken. If it finds a group of pixels that it can identify as an edge to something, it can highlight that edge and enhance the shape it sees. But what does that mean for NIBIRU? Let's take an image showing something seemingly out of the ordinary, and let's say that we want to make it more obvious that it's a planet. It's not a planet, of course, but that's what we're aiming for. Clear photographic evidence of a planet. But Photoshop and the like don't see planets, they see pixels. It doesn't know what clouds are, it certainly doesn't know what NIBIRU is. What happens then is that we steer Photoshop towards finding what we see as a planet. We control what filters to apply and in what strength and what order so that a planet appears in view. Photoshop doesn't care, it doesn't know. It's applying an edge effect to what it thinks is an edge after it added a bevel effect to the image that was made grayscale after the contrast was increased and the levels altered. In other words, both we and Photoshop are finding planets not in the original image anymore, but in the filters and adjustments that are being applied to it. This simply isn't helping the cause of determining what we're looking at. To a believer, of course, it's NIBIRU, plain as day, if rather dark and contrasty and only visible when thrown through a filter or two. But to us skeptics, it's a mess. It's a shape or two that we can only see when you point it out to us, and that bears no context to the original image whatsoever. It is more beneficial to us all to show the original image instead. But of course, those images don't show NIBIRU at all, do they?